All right, what's going on, everybody? It's your boy Crypto Wolf again, and today we are doing the second video for the TradingView PineScript tutorials. This one's going to be the PineScript language itself. In part one, I split it up into two parts because I don't know, there's a decent amount to it. I'm not going to say there's a lot to it. It's not exactly like C# or anything like that, but there was a little bit, and I tried to go through and simplify it in like some easier to read notes, which I am going to be going off of. And while we do that, we can watch what's going on with the Bitcoin price right now. We just got done seeing it dumping a little bit, not terrible, a little bit, but we shall see where it goes. I've got it on like a lower time frame just so stuff's moving over here and we're not just looking at the same candle for the entire video. But all right, let's get into it. Now, why would you want to learn PineScript? If you don't know what it is, go back and watch the first video. Basically, it is the coding language that TradingView uses to write its indicators. For example, you have Market Cipher down here. Market Cipher is an indicator, just like Market Cipher A up here with the little symbols and your moving averages and your EMA ribbons and RSI, stochastic RSIs, all of those are indicators, and in order to create those indicators, you need to use the PineScript language to do so. So if you want to make your own, or you want to do something, say you have a particular thing that you're looking for, or a way of judging entries and exits, and you wanted to write an indicator that showed you when those happened, you could use PineScript to do that and make life easier on yourself and just be able to have your own indicator and say, hey, all right, cool, it's showing me what I'm looking for without me having to like dig and do analysis and all that happy horse stuff. So let's get into it. All right, the first thing you need to know about when you are getting into PineScript language is what they call the execution model. And what that is it determines how a script is executed on the chart. A script being, you know, the code behind your indicator. Now, generally speaking, it executes once on each historical bar, which is, you know, all these bars back from the current one that is currently moving. And then once every time the current bar, as they call it, the real-time bar, updates. And this current candle, this current bar, updates every time the price or the volume changes. And you know, you can see it going up, you can see it coming down, as well as having the volume down here change as well if you have it turned on. Now, unless you are using a strategy, because when you were writing scripts, you can do a script an indicator, a strategy, or a library script. Not going to get into the library one too much at the moment, but basically between indicator and strategy. So if you're using a strategy, the script isn't going to update every single time the price or the volume updates, unless you turn on this, you know, calc on every tick setting, if you will. Otherwise, it just updates, you know, each time your real-time bar closes. Now, when the real-time bar does close, make these a little bigger here, it becomes an elapsed real-time bar. And you might say, well, okay, if it's over here now, if that bar closes and now it becomes the second bar, wouldn't that be a historical bar? Yes and no. Because unless you like refresh the page, refresh the chart, every time the real-time bar, like right there, the real-time bar closed, now it's over here, it's not going to look any different or change or anything like that. But the values being stored on TradingView's server might be like slightly different than the actual historical data. So that's why they call this a elapsed real-time bar. And then once this chart page, whatever, updates, if you change time frames, you go to a different asset, whatever it might be, and you come back to this one, it will now be a historical bar, and it's going off of that historical data that is saved on TradingView. Not a big thing that you really need to know about, but just, you know, we're talking about it, so I'm going to mention it. Again, this can end up being a slightly different value than the stored historical bar data. And it's important because variables reset every time the script is run unless otherwise instructed, meaning numerous times per single real-time bar called rollback. And we'll get into this a little bit in a little bit when we talk about variables a little bit more. But basically, you have variables, the values that are stored in those variables are constantly being updated because, you know, your script is being rerun every single time this candle moves, pretty much. Assuming that you are on a chart that is, you know, live right now. Like if you're on crypto, it's always going to be. If you're on stocks, you know, on the weekend, it's not going to be changing whatsoever. But every time this candle moves, it's rerunning your script and altering your indicator. Like in the case of this right now, you know, the VWAP's right here. If this were to start dumping all in this same candle, this VWAP's going to start moving down. And that's because those values are currently changing. It's, you know, live. And depending on how you establish those variables, it could keep changing it every time, or you can have it so that it is, you know, consistent throughout all the movements of that one candle. Now, FYI, the close, if you say, you know, you want the close value of whatever it is you're on, that equals the current price when you're on the real-time bar. Obviously, for all the historical ones, close is going to be what it closed at, but it considers the current price, the close, you know, part of the close variable, like up here, how you have your open, high, low, close on the real time. Script executes anytime the chart refreshes or updates, including if you go into the settings and you start changing inputs. You know, if you have a moving average and you change like how far back the moving average is looking, script's going to restart then. Or if you change the time frame, if you were to go from Bitcoin to Ethereum, whatever it might be. And that also, again, refreshes everything so that you're just straight historical data in here rather than that elapsed real time. But it's the last I'm going to bring it up, I promise. Now, the next concept that is a big one is called time series. And let's just read this. So market data is stored in a time series. Much like an array, if you don't know what an array is from programming, it's basically like it's a single variable that holds numerous values. So rather than just holding one value, it can hold an entire chart or matrix worth of values. And so the time series is very much like an array, but kind of not. Except that the index position of an array never changes unless you manually change them. So, you know, in an array, you say you have your, let's call it like a one-dimensional here. It'd be like your index positions would be like 0, 1, 2, 3, 4, 5. So you have 6 different values stored in there. And whatever is in value 0 is always going to be in value 0, the first position, unless you physically change it. But with a time series, value 0 is going to be constantly updating to whatever the current is. So like right here, our current price, I can't actually see what it is. Let me move this over a little bit. Okay, so our current price, 35,465. You can see it's constantly changing. So the close value for this candle is going to be constantly changing. So, you know, close brackets 0, which is the index position, will constantly be updating. But if you were to do close brackets 1, it's going to be the close of this candle. 2, this one, 3, this one, and you just move back from the current candle. Now, as soon as, you know, this candle prints, as soon as it completes and it moves on to the next candle is now going to be the 0 position, and this one will be the 1 position where it used to be 0. So on and so forth. Where do we leave off here? So in a time series, the 0 index will always be the current value, and as new bars are created, that value will shift to the next index number up. So close 10 will not equal the same value as close 10 30 minutes from now on a 5-minute chart. I think you should get the picture. And by the way, at any point in here, if you ever have any questions, by all means, throw it in the comments. I will try to do my best to answer your questions. You know, I'm not an expert, but I got a pretty good grasp on it. I've been going through it on and off for a couple weeks now, but I have been doing like regular coding for some years now, so it's not bad. It's really not bad. The next topic would be script structure. So now we're getting into like the actual what it's going to look like. How do you start? Where do you start? And so these are just placeholders, but you're going to start with the version of PineScript, then your declaration statement or statements, and then your code. Easy enough. 3 things that you have to have. Now, you could put comments in at new lines or at the end of lines. You know, if you can't really put a comment in the middle of a line because everything after that is going to be within that comment and it's not going to read it. If you don't know, comment is basically just, you know, stuff that you can write in for yourself or for anybody else who might be reading, just to make it, just to explain what's going on or make it more readable. And when it's processing the code, it skips over anything in a comment, except for the version, which is technically in a comment, but you know, it has to be on the first line and it knows to look there. You can also use line wrapping for longer lines, just indent 4 spaces or a tab, kind of like right here. And again, the version tells it which version of PineScript you're using. In the case of the most current one, it's going to be, you know, version 5, and you're just going to do the dash dash like any other comment, but then you're going to put the @ sign, version equals 5. You could do previous versions if you want to, but I'm not really sure why you'd want to. I guess if you're using some tutorial that's using like version 4 or something, like I kind of stumbled into in the beginning. The declaration tells it what type of script it is. So you can do indicator, strategy, or library. And you're just going to have, for the moment, you can just use blank parentheses without anything inside it. But generally speaking, you'll probably have something in there once you kind of get going here. And so all the text that's in blue on here is like actual code that you would write. I mean, minus the, whatchamacallit, the fucking braces over here. And all the orange text is just going to be like examples. So, and this is our example of what a basic script, you know, would look like. You have your version declaration, then you have your like main declaration statement. In this case, it's an indicator. I guess we could call it the script type declaration. It's an indicator. Now, double parentheses basically is just a blank string. More into that in a minute. So blank string, true. And those are the, drawing a blank here, parameters of that particular function. And if you were to hover over, say, indicator down here, you know, on the Pine editor, if you hovered your mouse over it, it would tell you in a little pop-up like what goes behind it, like what are the needed parameters. But in this case, it's basically just saying nothing, like you're not giving it a name. I forget what the second one is, and whatever default value of true. Again, declaration statement, this is your comment behind that saying what it is. And then just, you know, bars up. This is a lambda. Not going to talk about that just yet, but basically just saying it's this. And close is greater than open. Plot color equals, and we'll talk about that here in a minute more. If bar is up, variable declaration, global scope, color green, local block, local scope. And what that is it's not a great example of it, but global scope is like a variable or a function that is used throughout the entire script. Local scope is only used within the context of this one little block. Once you exit that block, it's gone, it's erased. All right, let's get on to something a little bit clearer. Identifiers. Now, identifiers are basically variable names. And so these names must begin with either uppercase, lowercase, or an underscore. They can have letters, numbers, or underscores after the fact. Case sensitive, so you know, you don't want to write, you know, when in all capital for your variable, and then when you go to call it up, you write it in lowercase. It's going to see 2 completely different things. And constants are typically in all caps, and temporary variables generally start with an underscore. A constant is a value that is not going to change. So if you wanted a constant for pi and you just wanted it to be like 3.14, you know, you could, all caps, you could write pi equals 3.14. And you know, you now have this constant that is just pi that you can just use capital Pi whenever you want to use it. The underscore, as far as temporary variables, are kind of like in regular programming, it's like throwaways. So if you're only using it within like a small local block of code somewhere, that it's just like, again, it's just kind of temporary. You're not using it anywhere else in the script or anything like that. And it just helps to delineate those things. All right, operators. Operators are not, you know, Navy SEALs, Delta Force. I mean, I guess they are. But in this case, they're going to be all your different plus, minus, equals, all that good, happy horse stuff. So a single equal sign is used to assign a value to a variable when initially declared. And this is probably one of the bigger differences I've noticed between PineScript and other languages. In other languages, you know, halfway down the, you know, the file, if you were to write, you know, x equals 3, after having already declared with and worked with x further up, it's just going to change the value of x to 3. But in PineScript, you only use it for when you initially declare a variable. So if you were to say at the very top of the page, you know, x equals 3, and then further down, you're like, okay, well, at this point, I want it to change to 5. You'd have to write it in a different way. You would have to do this semicolon equals, and that is used to reassign a new value to a previously declared variable. A little bit weird, a little bit overcomplicated. Yeah, whatever. That's the way they do it. Deal with it. And you can also use plus equals, minus equals. What do they call that? Asterisk equals, / equals, or percent equals. And these are just shorthand ways to do a little expression. Like in the case of plus equals, you know, if you said x plus equals 5, basically you would be taking whatever x is at the moment and just adding 5 to it and setting x equal to the answer of that. I know, not a great explanation, but that's what it is. It'd be easier to draw it out for you, but you're probably not going to use it all that much, to be honest. So, some of the basic ones: add, subtract, multiply, divide. And if you don't know what the percent sign is, it is modulus, which is the remainder after division. Why on God's green earth would you want to calculate the remainder after division? Basically, you can use it to see if it's an even or odd number. You know, if it's, you know, modulus 0, then basically you're looking to see, okay, if you're dividing, does it equally divide? You know, if you did, you know, 10 modulus 2, you'd say, yeah, that's good because it equals 5. It's not a fractional number. It doesn't have, you know, anything past the decimal point. And you can use it, again, to find odds and evens as well. But comparison operators are less than, which I hope you know. You learned this in grade school. You know, depending on which way the alligator's facing. Less than or equal to. The exclamation point equals is not equal to. A double equal sign is saying that it is equal to, and then you have greater than or greater than equal to. Now, these are all binary operators resulting in just a true or a false answer, also known as a Boolean operator. So you're not going to get a number from one of these comparison operators. And then you have logical operators, which is not the negation of the two values, and which is true only if both are true, or which is true if either of them are true. And again, so not would be like, are these two values not equal to each other? And if they are not equal, then the answer would be true. I know, kind of weird. I don't think I've ever actually used it myself. But then you have this ternary operator, which is the question mark semicolon. And what that is it creates a conditional expression a little bit beyond your basics here, but good to know because it's going to come up and you're going to see it a lot, especially if you are looking at the code for some of the standard indicators and such. You're going to see it come up. So what it is you have your condition and then your question mark, and then value when condition is true, semicolon, value when the condition is false. And basically it's saying, you know, is x equal to 3? And when x is equal to 3, then say y is equal to 5. And then over here, if it's not equal to 3, then y is equal to 10. Whatever you want to do. And that's basically just what it is. You're testing the condition. If it's true, do this, whatever's written here. If it's false, do whatever's written here. And you can nest these as well, putting you know, another one in the value. So you can actually have, you know, you have this ternary statement, this expression, and then say it equals to false. Well, then you can actually have another one there to further test it. And you could just keep on going like the Russian Matryoshka doll or whatever floats your boat. All right, and then you have these two brackets, the square brackets, and it is a history referencing index number, just like we were talking about the time series up there. Like how many candles back from the current one. And again, so this would be, you know, 0, it'd be index 0, index 1, index 2, 3, 4, 5, all that good stuff. And then just real quick, talk about precedence, which is, you know, if you have a big, long, you know, math problem, what is the order of operations? Hopefully remember this one from school. If you don't, the square brackets are going to come first. Then your positive, negative, or not. So if you have a plus x or a minus x, it's going to do the plus or minus or not first. And then it's going to do your multiplication, division, or modulus next. Then your plus and minus. Then your greater thans and greater thans and less thans. Then your equal to or not equal to will come after that. And then or, and then your conditional. So if you have a whole bunch of crap going on, a bunch of calculations, and you have a conditional in there, it's going to do the conditional last, which makes sense because you want it to do all the math first before testing a condition. And if you want to change the order that it does it, just put a certain, you know, block or a certain group or whatever in parentheses, and it'll do the section. It'll look at the section in the parentheses first. Okay, now on to the useful stuff. I've got past all the math stuff. I'm sure you guys love the math. Probably enjoyed your algebra and trig and calculus. I am sure. All right, so variable declarations. Now, these are basically the structure of it. So you have a declaration mode, and then the type. It's going to be what type of variable it is. Then you have your identifier, which is the name. And then you have your equals, which you're setting it to either an expression or a structure. Now you don't have to have the mode, don't even have to have the type. You can just have the name equals whatever. Or you have a tuple declaration. A tuple is a type of variable, but you can actually set multiple variables at the same time and they're kind of lumped together. And in this case, you would just have, you know, tuple name equals, or tuple names, plural, equals whatever. And we'll see some more of that later on because some of the built-in functions like moving averages and EMAs and SMAs and Bollinger Bands and all that stuff, they use tuples that way. Like the various variables that are involved are all just lumped together and you don't have to remember, type them out separately or anything. All right, declaration mode. The first guy up here is the variables declaration mode. It can be var or varip or nothing at all. And I'll explain those in a minute down here. The type is optional, as in almost all PineScript variable declarations. See the types list. We'll get to that in a second as well. Identifier is the variable's name. Expression can be a literal, a variable, an expression, or a function call. It's basically what you are setting the variable to. The structure can be an if, for, while, switch. Basically, you could have practically anything on the other side of the equals sign. Practically. Just about. Tuple declaration is a comma-separated list of variable names enclosed in square brackets. Example, square bracket, moving average upper band, lower band. Just like in the Bollinger Band, like example that I just said. Now, the various types of variables. You have integer, which is just a straight number, no decimal point. A float, which can have a decimal point. A Boolean, which is either true, false. A color, which obviously is a color. It's going to be a standard one that PineScript recognizes. I believe you can do RGBs, but don't quote me on that one. I know you can do it. I just don't know if it's part of the color variable. String, which is text, just regular text. You can put numbers in a string, but you can't calculate with them unless you change them back to a number type. A label, which is kind of a chart thing, like an actual chart label. A line, which obviously is a line. A box, which self-explanatory once again, or a table, which would be a collection of stuff, of data. And then you can have these with the brackets after it, which is going to be an array. So it's an array of integers, array of floats, array of booleans, array of colors, array of strings, yada yada yada. Basically means like a whole list of them. All right, you can also run if statements or expressions to the right of the equal sign, initializing to NA, which is not available or null. Oh, sorry, equals null value, but you must declare the variable type if you're going to initialize it to NA. Because if you say x equals NA, it doesn't have the slightest friggin' clue what type of variable you are trying to create. For all it knows, it could be a number, it could be a float, it could be a color, it could be, I was going to go somewhere dirty with that, but that's not really relevant. All right, tuples often equal function results, kind of like what we talked about up here with the Bollinger Band, which return multiple variables. So again, your BB function is going to return multiple variables. Like I said, declaration modes. So none, which is initialized on each bar or update. And again, it's going to depend how you initialize it for how it behaves. So like I was talking about earlier with the variables, each time this candle moves, it gets bigger, smaller, grows, the volume increases, decreases. Every time this changes, the variable is restarting to whatever it was initialized to, because it's rerunning the script every single time this updates. But so rude. If you were to declare it as like VAR, it will only initialize once and it will persist across multiple bars. So basically it's going to be like global, like you initialize, var x equals 10, and as you continue getting new candles, it's going to stay 10, unless you change it, of course. But even if you do change it, it will, continue to be whatever you changed it to. Or you can do the varip or VAR IP, which is intra-bar persist. And basically, it's just saying that it doesn't reset on each current bar update. So, like right now, let's say we had x equals 10 is what it got initialized to. But every time this moves, it's adding or subtracting to it, depending on which way it goes. And so let's say, okay, it's 9 now. Up, now it's 8. Up, it's going down. Now it's 7. Up, move back up a little bit. Now it's back to 8. And that variable keeps adding or subtracting rather than going back to 10 every single time the candle moves. But then when we get a new candle, now it resets back to 10. So it's only going, so the value is going to persist so long as you are on the current candle until you move to a new candle, and then it's going to go back to whatever the default value is, if you will. But if you were to do the var declaration, then, say we declared it equals 10, whoops, and we didn't change it got a new candle, didn't change it, got a new candle, didn't change it. Finally, we get like a new low, and every time we get a new low, maybe that variable changes to, 0. Then now it's going to be 0 until something else comes along and changes it. Kind of get what I'm saying? So yeah, so var is gonna last forever. Var rip will last so long as you're in the current candle, and declaring nothing at all is going to change every single time the candle updates and the script updates. So here are some examples of various variable declarations. So you got all caps again, which would be a constant, is equal to color.lime. Here we have I is equal to 0. So, no declaration mode, just I equals 0. Length equals input 20, which would be your default value. Length, which is, and this is a string because it has the quotes around it, is going to be the name of it. So when you go into the options on your indicator, you'll have a variable there that says length, and it'll say 20, and you could change it to whatever you want, and it'll change. Float, which is going to be remember, a number with decimal points. I'm not entirely sure how many decimal points it goes to. It may even just depend on whatever chart you're on and how far it goes. If you're on friggin' Shiba Inu, it might be going to a lot of decimal points. So float F equals 10.5. Close rounded to tick, big name, camel case. So the first letter is going to be lowercase, which is kind of standard, unless you're doing a constant. And then the first letter of each other word you capitalize. That's called camel case, because you got, it's coming up and then you got a hump, a hump, a hump. But that is equal to math.round to min tick. And, the math dot functions are basically just math formulas that are built into PineScript. So round to minimum tick, and then you're using the close value. ST equals TA, which is technical analysis. What's the word I'm thinking? Like calculations, algorithms, indicators. So, ST is going to equal TA.supertrend. 4 and 14 are going to be the input values for that one. And now, like we were talking about, you have var bar range equals float NA. So now this one's kind of interesting because there are multiple ways that you can declare, a null variable. And I'm going to get into this more in the next video, the part 2 on the language, but this right here is called casting. So you have your value, which is NA, or not available, or null. But if you're going to declare a null variable, you have to tell it what type it is. And in this case, it's a float. And so the way they did that, so rather, you could also do var float bar range equals NA. But in this case, they just did var bar range equals float with NA in parentheses, which means you're casting the NA to the type of float. You're changing it to type float, or converting it, I guess would be a better word. Var first bar open equals open, which is your open price for the candle. Var rip, saying that one again, float last close equals NA. So there we go. There's probably the more common way to do it. Casting is usually if you have you have a string, and that string happens to be a number, say it's something somebody has to type it in or something, and then you're casting from a string to an integer or a float or something. So you're trying to take that number from being just text into what it can actually read as a number and do calculations. But here's an example of a tuple where you have MACD line, signal line, hist line is equal to TA, MACD, and then your input parameters are close, 12, 26, 9. Which, if you did watch the first video, our little example one that we played with was actually a MACD, and those are the tuple of values that you get from doing that calculation. And you can also have it take up multiple lines. So in this case, plot color is equal to if close is greater than open, color equals green. Else, whoops, the color equals red. And we're going to get into, if else statements, if then type statements, and loops and all that stuff in the second video. I may even put it out today just in case you want to just hit them back to back and get it over with. But yeah, you can have, various things behind that equal sign. Just remember, if you're doing something like that, you want to have your indents, because then it knows it's like a multi-line kind of thing going on there. And look at that, man, price came right down to that trend line. Man, a couple days ago, I was like, is it going to come down to that trend line? And I'm like, I don't know. And then I wasn't paying close enough attention and should have did another short, because this sure as shit came right to that line. Look at that. Oh, what are we off by? Like a couple dollars? Like $4? Maybe killing them. But that is all for now. Let me know if you have any questions, comments, suggestions, critiques, or criticisms. I don't care. I'll take it all. Let me know what you thought. And I know it's kind of boring. I tried to make it a little less boring, and it's definitely way shorter than the actual tutorial, just to show you guys here. And I'll leave a script to this. It's the PineScript version 5 user manual. We basically just went through 1, 2, 3, 4, 5 chapters. Not too bad. What are we doing? 36 minutes. I think we did fairly well. But I mean, you can see just for the operators that we were talking about, there's a decent little chunk of reading right there. Script structure. Again, half decent. Little chunk of reading right there. I do recommend, though, if you're having trouble with the time series concept, to read this. You may even have to read it a couple times. It's not super long, but it can be a complicated thing to get your head around if you are not used to doing anything with, the charts or programming or anything like that. But all right, I hope you guys found this useful, and I will see you on the next PineScript tutorial. Remember, keep being a badass. Life is short, so stay happy. Do something to better yourself. Keep improving. Keep preparing. Be a good little Boy Scout. All right, later.